Good morning, good afternoon, and good evening, depending on where you are watching us from. You're welcome to Champ World Maths, an online channel that explains mathematics in a way that everybody will understand. In today's lesson, we are looking at decimal to binary conversion using binary tables. So we are going to be using binary tables to convert decimal numbers to binary numbers. And then we all know that decimal numbers are base 10 numbers. So we are going to use binary tables to convert the base 10 numbers to binary numbers, which can also be called base 2 numbers. Now first, how do we develop a binary table? This is a binary table. 1/16 times 2 will give you 1/8. 1/8 times 2 will give you 1/4. 1/4 times 2 will give you 1/2. 1/2 times 2 will give you 1. 1 times 2 will give you 2. 2 times 2 will give you 4. 4 times 2 will give you 8. 8 times 2 will give you 16. 16 times 2 will give you 32. 32 times 2 will give you 64. 64 times 2 will give you 128. And if you have a very big number to convert, you may need to multiply 128 by 2 to give you the next number. Now from this 1 up to this 128 and above, it is for whole numbers. When you are converting whole numbers, you make use of from 1 up to this point here. While this side here, it is used for conversion of decimal fractions. So for the sake of this lesson, we are going to be considering from 1 up to this 128 and beyond. So we have a number of examples that will help us to convert numbers from base 10 to binary. In the first example, we have change 15 to binary. 15 is in base 10. So we have to change it to binary. So now this is the binary table we are going to be using to change from 15 to binary. It is important to note that the number you have here must be bigger than the number in question. The number we are using to convert, we must have a number on this table that is bigger than that number. And that is the reason why we don't need to write 32 and 64 and the rest of them, because we have gotten 16. We are up to 16, and then 16 is bigger than 15. So the only thing we need to do is to find out the numbers on this binary table that we can add up that will give us 15. If you look at this closely, you would see that when you add 8 plus 4 plus 2 plus 1, all of this from 8, 4, 2, 1 will give us 15. Now for us to avoid making mistakes, we are going to look at these numbers here. Obviously we are not going to use 16 because 16 is bigger than 15, but we can use 8. So when we subtract 15 minus 8, our answer is going to be 7. So looking at these numbers here, already we have used 8. So the next number that is less than 7 or equal to 7 is 4. So we will subtract 4. And if we subtract 7 minus 4, it is going to give us 3. Now, looking at the next number we have here is 2. 2 is less than 3. So we are going to subtract 2 out. If you subtract 2, you are going to have 1. And then we have 1 here. If you subtract 1, it's going to give us 0. So it means we are using 8, 4, 2, and 1. So all of these we are going to indicate If we are using any of these numbers, we'll put 1 representing yes. So we are using this 8, we'll put yes. We are using 4, yes. We are using 2, yes. And we are using 1, yes. So we have 1, 1, 1, 1 base 2. So it means that 15 when converted to base 2 is going to give us 1, 1, 1, 1 base 2. Now in the second example, we are to convert 46 in base 10 to binary. So we need a binary table that at least has a number that is bigger than 46. Now this is our binary table that we'll be using. Remember, we can generate it by writing 1 and then multiplying it by 2. 1 times 2 will give us 2, 2 times 2 will give us 4, 4 times 2 will give us 8, 8 times 2 will give us 16, 16 times 2 will give us 32, and 32 times 2 will give us 64. If you have a number that is bigger than 64 that you want to convert to binary, then you need to keep on multiplying by 2 until you have something on the binary table that is bigger than the number in question. We need to pick out the numbers here that we can add them together. That is going to give us 46. Obviously, we are not using 64 because it is bigger than 46, but we can pick 32. And if we pick 32, we'll subtract it from 46 to know how many will remain. So 46 minus 32, 6 minus 2 is 4, and then 4 minus 3 is 1. So if you pick 32, it's leaving us with 14. Obviously, we cannot use 16 because 16 is bigger than 14 that is remaining, but we can use 8. So we will now take out 8, subtract 14 minus 8. So 14 minus 8 is going to give us 6. So the next number we have here is 4. 4 is less than 6. So we can subtract 4 out from 6. 6 minus 4, that will give us 2. And then we have 2 here. If we subtract 2, 2 minus 2 is going to give us 0. Therefore, we are making use of 32, making use of 8, making use of 4, and then we are making use of 2. So let us indicate here. 32 is a yes because we are making use of it. 16 is a no. We are not making use of 16. We are making use of 8, a yes. We are making use of 4, a yes. We are making use of 2, a yes. We are not making use of 1. So we have no represented with 0. So at the end, we will have our answer as 1, 0, 1, 1, 1, 0, base 2. In the third example, we are to convert 100 base 10 to binary. So we need to develop our binary table. This is our binary table. So just like I explained in the previous examples, you can develop this table by beginning with 1 and then you multiply it by 2. That will give us 2. Multiply by 2, it will give us 4. You keep on multiplying by 2 until you get a number that is bigger than the number we are going to convert. So in this example, we are converting 100 to binary. Now the question is, which of these can we add up without repeating a number that it will give us 100? Obviously, we are not going to use 128 because it is bigger than 100. But we can use 64. So let us subtract 100 minus 64 to know what is remaining. And then 100 minus 64 will give us 36. So it is remaining 36. Now, looking at these numbers here, we have 32 to use. because 32 is less than 36. So let us subtract 32 out. If you subtract 36 minus 32, it is going to give us 4. And then the next thing to use here, 16 is bigger, 8 is bigger than 4, but we can have 4 here. So let's subtract 4 out, then that is 0. So it means we are making use of 64, 32, and 4. Now beginning with 64 is a yes, because we are using it. We are also using 32, that is yes. We are not using 16, that is no. We are not using 8, that is no. But we are using 4, that is yes. We are not using 2, that is no. We are not using 1, that is another no. So this binary is giving us 1 1 0 0 1 0 0 base 2. So I am going to leave you with an exercise to do on your own, and then tell me what the answer is in the comment section. So our classwork is change 130 in base 10 to binary. Thank you so much for being part of today's lesson. If you have not subscribed, please do well to subscribe and share to your friends. Thank you for watching. See you in the next lesson.